to our speaker. She is Rosetta D'Souza, software engineer at Blue Cat Networks. So I will stop sharing now and mute myself.
Hello, everyone. My name is Rose, and I work at Blue Cat Networks. I actually just want a confirmation that everyone can hear me and see my screen.
Yeah, I can hear you.
Okay, awesome, great.
I can hear you.
Thanks. So hi, my name is Rose, and I work at Blue Cat Networks. Blue Cat makes enterprise software that delivers critical network infrastructure, and the product that I work on is built with Docker, and I've become really familiar with it, which is why I decided to give this talk as a high-level introduction to Docker and why you should care about it. Just to quickly go over what we're going to talk about today, we'll first cover what is Docker and what are containers. Then we'll talk about the advantages of containers. And then I'll do a demo of running a couple of Hello World containers. We can then talk about orchestrating containers and then discuss microservice architecture. If you have any questions, like Stella mentioned, please put them in the chat and we'll get to them at the end. So what is Docker? Docker provides us with the tools to build, distribute, and deploy containers. Which brings us to what are containers. A container is a package that contains all the code and dependencies that a program needs to run. So this package will contain all the compiled code and also everything else the code needs to run, like settings or libraries. When this package is built and distributed, it is an image. And when a run command is run on this image, a container runs. Think of the image as a template for the container, and think of the container as a running image. So why should we use containers? Containers are easy to develop for. Once the code is written and we figure out exactly what the code needs, we can build the image. And this image can be reliably expected to run on any operating system. So this image will contain the code and dependencies the program needs. And we can run a container based on this image on any operating system. There is a huge advantage in development if you don't have to figure out how your program will interact with the intricacies of all the potential OSs. Since Docker images don't contain anything apart from what the container needs to run, they are the smallest possible in terms of size, and this makes them really easy to store and download. Docker provides us with a great distribution system called a registry. A registry is a system to store and deliver images. Registries can be on the cloud or on-premise. They can be public or private depending on the use case, but they allow for images to be easily stored and downloaded from. When you're ready to publish an image, you can push it to the registry. And when you want to download an image from the registry, you just pull it. Docker has a default registry called Docker Hub. If you don't specify a registry when pulling an image, Docker assumes you need Docker Hub and tries to pull the image from there. Once you download an image and run the container, since the container does not contain its own operating system, and since it only contains what it needs, the container starts really quickly. The speed with which images can be downloaded and the reliability with which we can expect containers to run is what makes Docker so popular. Just to get a little more perspective on what containers do, let's discuss virtual machines for a little bit. Imagine you want to deploy an application on a server. You could deploy it directly on the server, but running just one application on a server is usually inefficient. Usually, servers have the capacity to run multiple applications. But applications may be built to run on different operating systems. What if we want to run different applications on a server, but they all require different operating systems? Without virtual machines, we couldn't deploy these applications on the same server. They would each need their own server, and this is a big limitation. Virtual machines are a solution to this problem. We can run virtual machines by running hypervisors, which are virtual machine managers. They are a type of software that lets us run an operating system inside a running operating system. The hypervisor allows a virtual machine to use a portion of the host hardware. It can also portion up these host resources between multiple virtual machines. So if we had to deploy applications that run on different operating systems, we can deploy a virtual machine for each application, where the virtual machine would run the required operating system. Then we could run all these applications on the same server. Here we can ask the hypervisor to give the first application 50% of the server's resources and 25% to each of the remaining ones. And the hypervisor will distribute the CPU, the memory, and the storage accordingly. So let's say we're running these 3 applications on our server inside 3 virtual machines. And the white bar can represent the total resources of the server, like the CPU and the memory. Let's say the host operating system and the hypervisor take up this red space on the server. This is not to scale, it's completely arbitrary, just to give us a sense of resource consumption. Now let's assume each guest operating system takes up this blue space. Then the operating system in each VM would take up this blue space together, and this leaves the remaining space of the server available for the actual applications to use. And this is the overhead we see when we deploy applications inside VMs. But what if we want to deploy these applications as containers instead? We could package all the code and dependencies into an image and deploy the application as a container. But what does the server need to run containers? And this is where Docker comes in. To run containers on a machine, we need to install the Docker engine. When we install Docker on a machine, usually the Docker client and the Docker daemon get installed. The Docker client interprets commands given to it and makes API calls to the Docker daemon. Essentially, this is a client-server model, and the Docker daemon implements the Docker API. The client may not be located on the same machine as daemon, but both these components together make up the Docker engine, but often Docker engine may be used just to refer to the daemon. The Docker daemon runs containers and is responsible for distributing the resources of the machine amongst the containers. And using Docker, we can run several containers running different applications on one machine. Then in terms of overhead, we would only need the space taken up by the host operating system and Docker engine, and the running containers would be able to access the rest of the space. This is an image from the Docker website, and here is a side-by-side look at containerization versus virtualization. As you can see, there's a lot more resources available to apps that are deployed as containers, as opposed to apps deployed inside virtual machines. The other thing to note is that the guest operating system takes a long time to get installed and start up, as opposed to containers that usually get started in a matter of seconds. But it's important to remember that both containers and virtual machines allow us to automate deployment. And in the real world, a common solution is to deploy containers inside virtual machines. So now I'm going to do a quick demo and show you some simple Docker commands, and then we'll run a couple of Hello World containers. So first, I just want to show you that you can browse the default Docker registry, that's Docker Hub, via the browser. And we're going to run containers based on 2 Hello World images. This is an official Hello World image, and it'll just print some text to the console, and that's all that it's going to do. And this is an image that I've published to Docker Hub, and it's an unofficial image. Please be careful with unofficial images, but I've built this image, and it just runs a PHP script that prints out Hello World, specifically this PHP script. And the container acts as a web server, so I can access it through the browser. So let's get started with a couple of simple Docker commands. So we're going to type in Docker version in terminal. And we can see the Docker client and daemon and their details. These are the versions running on this machine. And another command is docker info. And we can see the number of containers on this machine, the number that's running and stopped, and the number of images locally available on this machine. So I'm just going to clear the screen, and let's do docker ps. This command is very useful, and it gives us the running containers on this machine. And if you add a option -a at the end, it'll give us the stopped containers on the machine. And Docker images will give us the images locally available on this machine. I've gone ahead and downloaded the image I published to Docker Hub because it takes a really long time to download. But we're ready to actually run containers now. So let's do Docker run hello world. So we're asking the Docker engine to run a container based on the hello world image. And as we can see, this image was not available locally. So Docker decided to pull the image down from Docker Hub. It executes the code from inside this container. And once the code has finished executing, the container stops. So if I run Docker PS now, we see that this container is no longer running. And if I do Docker PS -a, we see a stopped container on the machine. So I'm not going to talk about how to build an image or how to network with Docker in this presentation. So if you don't understand something in this next section, try not to worry. I'm really just trying to show you how to how to interact with a running container. So I'm just going to clear the screen again. And now we're going to run that image that I had made. So we're going to do Docker run -d. This -d allows us to run the container in the background so we can keep interacting with the terminal. And then I'm going to give it another option, which is -p 8080:80. This -p allows us to map a port from my machine to a port on the container. So it's going to map port 8080 on my machine to port 80 on the container. And then I'm going to, this is the name of the image. And it looks like the container has started. So let's make sure it's still running. And you can see that it has been up for 5 seconds. And if I go back here and I go to localhost 8080, because we had mapped port 8080 to port 80 on the container, we can see hello world, which is what the script is outputting. And let me just break this container down just to prove that it is this container that we are looking at in the browser. So when I stop this container and we refresh, we can no longer reach it. Okay, so I just want to go over that workflow again. I'm going to focus on us running the official image of Hello World. And so we have our machine, and then we have Docker engine installed on it. We tell the Docker client to run a Docker container based on the Hello World image. And the Docker client makes an API call to Docker daemon to start the container based on the image. The Docker daemon checks to see if this image is available in the local image store. If it's not available locally, since we haven't specified a specific registry, the Docker daemon assumes this image should be available on Docker Hub, the default registry. So it pulls the Hello World image from Docker Hub. That is, it makes a local copy of this image. Then it runs the code in this image. That is, it runs a container based on the code and settings inside this image. And once the code is executed, the container stops. So what if you wanted to deploy your applications over a lot of servers? Maybe you have 10 servers, maybe you have 100 servers, and you want to run a few different applications across all of them. Deploying each of these containers, maintaining them, and if they have fluctuating demand, for example, this would get very challenging if you were doing all of this manually. And this is where orchestration comes in. Think of an orchestra. There's this conductor conducting the orchestra. The conductor knows what the music should sound like, and they have a unique perspective since they are in a position to hear everyone in the orchestra. For example, the tuba player may not be able to hear the violins while playing the tuba. The conductor is responsible to ask the tuba player to play quieter if necessary, or bring in the percussion at the right moment, or just synchronize everyone so that the music sounds exactly right. So using this analogy, the orchestrator is the conductor, and our containers are the musicians. The orchestrator is responsible for managing the containers. You've probably heard about a popular orchestration technology called Kubernetes. There's often confusion between Docker and Kubernetes. Docker is the tool that allows you to build images and run containers. Kubernetes allows you to manage these containers. Docker relatively recently introduced the swarm mode, so Docker now also has an inbuilt orchestrator. Imagine your application was made up of 3 services: a front-end service, a back-end service, and a database service. And you had to deploy it across 5 servers. Each of these servers will have both the Docker software and the orchestration software. Maybe you want 2 containers running the front-end service, 2 containers running the back-end service, and just 1 container running the database access service. And maybe you want to give the back-end service a lot more resources, but a lot fewer resources to the front-end and database service. You can tell the orchestrator to run them this way, and the orchestrator will decide which servers to run these on depending on available resources. Now imagine that there is way too much demand for the front-end service. The orchestrator will recognize this and increase the number of containers running the front-end resources. When demand drops, the orchestrator will go back to the desired number of containers. What if a server running a front-end container goes down? The orchestrator will again recognize this and redeploy the container on another server. If we were trying to simulate the orchestrator ourselves, a challenging thing we would have to do is figure out which container to send communication to. For example, if a user is trying to access the front-end service, we would need to decide which container was available and figure out how to access that exact container. Similarly, the front-end service, if it was trying to access the back-end service, it would need to know which backend container is available and the IP of the container it is trying to reach. An orchestrator takes care of all of this. It gives us a single point of contact for each service and decides which container to communicate with. To understand how to use containers to their full potential, we need to talk about microservice architecture, and we can do that by contrasting it with monolithic architecture. When we begin to develop an application, we start a project. And when that project is built, it gives us one deliverable to deploy. The whole project gets put into this one executable and deployed from that one executable. And as we add functionality, we keep adding to that project, and eventually that project gets very big. But we follow best coding practices and keep everything modular inside. When this application gets built, it still gets built into one big deliverable that then gets deployed. This is a monolithic application. Now imagine if instead of this massive project, we break up the project into smaller projects. Each of the smaller projects takes care of one of the big functions of the big project. Building these smaller projects will create a mini application or microservice. All these microservices together will behave like one large application. These microservices can be deployed as containers, and we'll talk about why we would want to do that in the next slide. So both monolithic and microservice architecture have pros and cons. Monolithic applications can be huge, but microservices tend to be much smaller in size. With monolithic architecture, the more developers you have, the more costly it becomes to develop and maintain the code because of the complexity the size of the application creates. With microservices, developers will normally work inside one microservice or a few microservices and do not need to understand the whole application to make changes. Also, the bigger the application, the longer it takes to deploy it. And in monolithic architecture, even a small change will need the whole application to be redeployed. Microservices, on the other hand, can be deployed independently of each other and can be scaled up or down independently as well. Monoliths are less efficient in terms of scaling, as we must scale up the whole application. Changing the technology for particular functionality in a monolithic application can be expensive, as any changes will affect the whole application. In microservice architecture, each microservice can use the technology best suited to its functionality. Similarly, a bug in a monolithic application will take down the whole application, whereas if there's a bug in a microservice, the other microservices can continue running. Microservices aren't the best for every situation, though. For example, monoliths are relatively easy to architect, but designing microservices requires skill and experience, so we don't introduce new problems. Communication inside a monolith is faster and cheaper as well, because communication between microservices takes place over a network. So just to summarize everything we talked about, here are some takeaways. We talked about how Docker allows us to build and deploy containers, and containers are packages that contain the code and everything it needs. Containers can be expected to run on any operating system, and because of this, they are very fast and reliable. Orchestration allows us to deploy containers over several machines and automate maintenance of these containers. And then we talked about software architecture and how containers lend themselves to this method of software design. I've definitely oversimplified a lot, but I wanted to introduce a lot of big concepts here, and I've really tried to stay out of the weeds. There's other software that facilitate using containers other than Docker, but I'm most familiar with Docker, and it is the most popular. So I've mostly referred to it throughout. But the concepts I've talked about will apply to any containerization and orchestration technology. If you want to learn more about Docker, here are some resources. Let me just see if there's any questions. Okay. Yeah, you can drop them in the channel, or feel free to unmute yourself and talk if you have any questions too. I'll give it a few seconds. Okay.
Rose, this is Bhavna. I just wanted to say this was so clear. I really enjoyed the presentation, and it was, you laid out the different concepts really well. So thank you for doing that.
Thank you. That's really nice. To be honest, that was a bit of work, but also a lot of people gave me feedback, and thank you to everybody who gave me feedback for this presentation. Really appreciate it. Okay. Okay, so feel free to reach out to me on Slack or on LinkedIn if you have any more questions. I'd love to chat, and I hope this was useful, and thanks for listening.
Yeah, it was very well explained, Rose. Thank you so much.
Thank you, guys. Okay, I'm going to stop sharing, and hopefully that's good.
Thank you, Rose. That was amazing.
Thank you.
All right. Let me share my screen again. So our next talk will be about recognizing whether something is bacon or not bacon with some machine learning. Our speaker is Maxime Rouiller. Sorry, horrible
no problem.
French last names.
The butchering of my name shall continue.
I just added one more tick to that. Sorry about that, but please take it away.
No problem. All right, let me just share my screen. Everyone can see this? And let me just get the chat window somewhere. So in case there are questions, it's always good. I can't. Apparently I need something else, or I don't know. Where's the button for chat? No chat. All right. Oh, here you go. Okay, got it. All right. So, bacon or not bacon, solving my breakfast needs with machine learning. My name is Maxime Rouiller, French Canadian, just a little bit east. If you're in Toronto, if you're anywhere else, it's pretty much west. I'm from Montreal, and I do speak very fluent French. So if you're interested in speaking French, go for it. Like, sky is the limit. Before we move any further, like, all this content has been already summarized into a Learn module that you can access with this URL. I can also just drop it in the chat real quick. Bacon, not bacon. Let me just add HTTPS on that. And basically you can just do it on your own with no credit card, nothing. You just need, I think it's a Microsoft account or something, just to make sure that we're not getting hacked. But otherwise, it's pretty much free to use. All right, so what are we known for, right? Like, as a Canadian, poutine is like the main staple food that we have. And it's like one of the best food that I've ever had in my entire life, and I've been to many countries. But there's one thing that I really love, and for me, it is all about bacon. I have it pretty much every week, not because I'm a big meat fan, although I am, but mostly because bacon is the main thing, and this goes very well with breakfast or with burgers or pretty much anything else. So here's the need. I want to create an application that will recognize bacon in pictures. I want to make sure that if a picture has bacon on it, I want to know about it. So here's the plan. We need first to create some resources that are going to be able to provide all that we need. So we will need to go on Azure and create all those. Then we're going to build our model. It is important that we build a machine learning model that will be able to recognize our pictures, and I will go through all the different options. And then finally, we will want to integrate our model into an application. The application that we have is something going to be very simple, but it can be run pretty much everywhere because the output is going to be something pretty much universal. So what do we need? So the basic spec here is that we need to be able to recognize the picture when there's bacon, but we also need to be able to improve our model over time. As there are more pictures becoming available to us, as we're testing more and more, we want to make sure that we refine our model a little bit more every time. And of course, we need an application that's going to be able to use this model. So the first step we're going to do is we're going to head onto customvision.ai. This is the main area for everything custom vision on Microsoft Azure. And there are multiple ways after that to go through this process. So I'm going to enumerate the option right away, but we're going to be able to talk through them as well. And there's two things here. There's two types of classification, and there's classification and object detection. And there's a major difference into them. And classification basically say, here's tags that are related to that full picture. And object detection is about identifying subset of that picture and basically saying, okay, this is that object. So a main picture will allow multiple tags at different areas in your picture. For example, if you're trying to identify license plates from pictures taken from the overhead of a highway, you want to make sure that you're capturing only the license plate. The rest doesn't really matter for you. So you need object detection for that. But in our case, we just want to make sure, is there bacon in the picture, yes or no? And if yes, we want to have this tag return or not. So for our case, we're going to be using classification. It's also way easier. So let's get started. So for getting started, customvision.ai is pretty much the only thing you need to go at the beginning. And since I'm already logged in, let me just show you the page in anonymous or in private in this case. What it looks like, it's pretty much just this. Allows you to say, well, what do you want to do? Upload images, train a model, and evaluate. That's what we're going to be going through. As you click on sign in, you're going to be taken to this page where everything that you have on Azure that is linked to your account is going to be showing up here. So let's start by creating a new project. And we're going to call this, I've not done this demo enough, bacon, not bacon. And we're going to create a new resource. So in my case, we're going to name it bacon, not bacon. And I'm going to put that on my subscription. And we can just pick any existing resource group, or I can just do bacon, not bacon again, and just put it into the East US. Regions are important because they determine the latency you have with that service, but otherwise they're not really that important in terms of functionality. They're pretty much the same. So let's just pick this one. Now, on that option menu, you could possibly just do, I just want to do training. I don't want to do any prediction. So you could specialize your service you're creating at that point to do either one, the other, or both. In our case, we're going to be doing both. And again, since I'm closer to East US, so in this case, I already have a free version of Custom Vision. So I'm not going to be able to create another one. So I'm going to be using it as 0, which is standard, which is paying by usage as well. So let's just create this one right now. And all right, so we have all of our resources. Just make sure that we're using the right one. All right. And here are our project types that we talked about earlier, right? There's classification and the object detection. And things changes when you go through them. And I already explained what classification is and object detection is. So we want to keep this a little bit simpler. So we're going to go with classification. In our case, we could go either multi-label or multi-class. And for me, I'm going with multi-class because, again, simplicity. Every time you do multiple, you need more options and you need more data. You want to keep things simple. So in our case, single tag per image, do you have bacon or not in that picture? And now there are domains. And the domains will basically tell the resource, the custom vision service behind what type of model are you expecting out of this. If you have an idea of what your project is going to be like, you can pick something that is already specialized. In our case, for example, bacon is a type of food. So this model is going to be more specialized toward anything that is centered around food. So if you're trying to detect apples and bananas or bacon or not bacon, if you're trying to detect anything that is related to food, this model is going to be already trained, already specialized for this. There's also models for landmarks and retail, but if your model does not fit in there, like just go with general. That's going to be the main one, and it's going to perform reasonably well for most areas. So in our case, we have two options because we have food, but we also have food compact. So what's the difference, right? I mean, food compact, what is the difference? Well, by clicking on it, you have something here like that's pretty self-descriptive. And in this scenario, it's export capabilities. As in, we want to be able to export our model. So why would we want to do that? Let's say that you have, I don't know, a mobile application that you want to be able to run your model on, but you don't want to have access to the internet all the time. So let's just say, I don't know, that you have somebody that is trying to do image recognition out in the field with no access to internet in any ways, or the access is prohibitive. You want to be able to export your model. So that's why we're going to be picking the food one, because you could pretty much just install it anywhere on any device, and you don't need to call into Azure to do this kind of thing. You just pick the model, and it's basically the cheapest version you can have to use it anywhere you want. So let's create this project. And at that point, all right, so we're going to have main page with pretty much nothing here loaded. And the first thing they're going to ask us to do is to load up some images. I'm just hoping to see that the loading button here disappear. The Wi-Fi is always interesting. All right, so it's going to ask us to load some images. So let's do so. The first thing we're going to do is I'm going to go into my bacon, not bacon sample file here, and we're going to go into training. And that structure, by the way, this is not just me being like super organized for a demo. It is something you want to have as super organized. May the demo gods be all in our favors forever. I agree. So this structure is actually something you want to have, because there's nothing worse than training your model with your testing data. You want to make sure that those two are really separate, because just like if you were going through an exam at any kind of school, if the teacher were preparing you for the exam with the actual material from the real final exam, you would know all the answer by heart, and you would be over specialized for that. So what you want to have is you have a separate set of data that is one for training and one for testing. So that's what I have here. And the training and the testing are not the same. So every time I'm going to be doing a quick test, I'm going to be picking from the testing folder. Every time I want to train something, I'm going to be into the training folder. And we want to make sure that we're not crossing the streams. It's just back to Ghostbusters again. Don't cross the stream, bad things happen. So in our case, let's train up some bacon models. In this case, I'm just going to load up 5 images, or you know what, just single image, and we're going to call it bacon, because this one definitely has bacon in it. We're done. And I'm going to generate a whole bunch of different errors, but it's basically just to show you, like, the things you should expect to see here. All right, so your project can't be trained just yet. Make sure you have at least 2 tags and 5 images for every tag. So let's just make sure that we're satisfying the requirement for this project. So we're going back to our bacon. Let's just this time, let's pick 5. And I'm going to call bacon again. This time the tag is already pre-filled, so we don't need to retype it again and again. It's already there. Upload all the 5 files, and here's something important I want to show you is that it actually detected the duplicates. So you don't really have to be afraid that, like, oh, I'm going to be adding the same images multiple times. If you're actually uploading exactly the same image, it's going to detect it, and it's going to make sure that we're not uploading it multiple times. All right, and we need images from the other side of the pond, which is the not bacon. So training, not bacon. Let's pick 5. We can discard this notification here. And this time we don't have, let's do not bacon and upload all of our 5 files, right? 5 image uploaded successfully. So now we can train our model and we can do a quick training. And of course, everything is going to be like 100% because there is nothing to test against. So that's going to be our first iteration. And we can could probably do a small test on it. So let's do a quick test. And just so we're sure, let me just open up a new window, look for bacon and image. And there are so many of them. Let's just, I don't know. Let's bake. Yeah, this one is good. So copy image link. We're going to close this down. And we can test it out here. We can see 99.9% it is bacon. So that's one of our tests. That's cool. And we can also do a little search for, I don't know, pancakes. Do another test. This one is good. There's definitely no bacon in there. I hope those are not part of my existing pictures, but that's the risk I'm willing to make. So here we have not bacon, 78%. So it is not super accurate, but it's already way better than just guess. And if you're setting your threshold on is it bacon or not to 75%, you're pretty much guaranteed to have something that is relatively quick and relatively performant in terms of model. And that is just with like 10 images, which is not that much. So, but we can make our model a little bit better. Like I said, the goal here is to improve it and increase it. We need to keep on training that model to make sure it becomes even better, because we have a fun scenario now, but in other cases where the learning actually matter, or it might be health related, or might be something that is really important, you want to make sure you have more data and accurate data. And my data is not accurate in any shape, way, or form. I'm just having fun with that project. So let's add more, right? We're going back into our training, and this time I have this whole file full of bacon, including here the bacon in terms of a football, which is always amazing for American friends. And this time we're going to tag it with bacon. We're going to upload all the files. Again, 5 image were duplicate, so it's perfect. So we can always just do Control A and upload everything. And let's train it again, right? Because we have more bacon, we have more accuracy, right? So here's one of the issues that we're going to run into now. As we have now 15 images of bacon, and we have only 5 images of not bacon. And you see here this little like warning sign, unbalanced data detected. The distribution of images per tag should be uniform to ensure model performance. So the point here is not that I have 15 images and 5 images and the number is different. It doesn't need to be identical. It just needs to be kind of the same in terms of ratio. Right now I have a 3-to-1 ratio. As in I have overtrained the bacon tag way too much. And by the way, I'm sorry for the dog. Somebody just rang the door. So we have way too much bacon data compared to the not bacon data on the 3-to-1 ratio. So we need to fix that. So let's go back to training images. And we're going to go back into not bacon and we're going to add the rest. So a whole bunch of them, not bacon. My pancake picture is not in there. We're safe. So same message we're going to get this time again. 5 images were already detected. There were already duplicates. The other one are completely there. We just need to do a train. And we're going to do a quick training here. So we could go into more advanced training where we can spend literally hours of time training your model. That will cost you time based on the amount of hours it's actually training. So if you have like thousands of images, you may want to go that route. But in our case, it's just quite simple. So here now we have 15 to 15. So we have a 1-to-1 ratio in terms of images. Now there's no more errors, and we can run some more tests. So let's browse a little bit of the images I have. And so I have some, let's not use the training data, right? Let's choose the testing data. So I have a bacon one here. Amazing picture, 90% sure. It's bacon. I can use the other one right beside. Like that is raw bacon. And this time it's 99.6, so it's pretty good. So let's go with the other one here. Sausages. You see the error here. Like 90% sure, like this is bacon, right? It's mostly because when you're looking at the picture itself, your brain has already been trained to know what bacon is and what a sausage is. Like you've been trained as a kid, like to identify word and matching images to words since you were a toddler, and you've been trained for this. Our model now has not been trained for this. For him or it, I don't know what that is. The mathematical representation of this picture say it looks close enough to bacon that I'm willing to bet this is bacon, and it's not bacon. The reason for this is if you're looking at a picture of the sausage and you're trying to decompose like what it looks like, it's kind of meat. It's kind of been cooked in fat, so it has the same kind of like listening and the same images that are around it. So you don't know exactly how the model works. And from an interpretability point of view, that means that you're never going to really know for sure what made the model tick into like what is not bacon or what is bacon. But in our case, we know now that like this sausage here has been identified as bacon. So we kind of need to provide a counter example. So maybe my initial data was not good enough. Maybe I did not include pictures of sausages and say, this is not bacon. So I need to rectify that. So let's fix that. So let's go back into the training images, and we're going to add some more. And this time we're going to go into our training set, and we're going to take breakfast sausages. So I took a few images of sausages, and I'm going to take all of them, and we're going to add them and say not bacon. All right, so that was quick. And now we're going to train that model again. But now we have 15 images of bacon and 18 images of not bacon. So is the model going to be unbalanced or not? Well, the answer to that is it's not, because it's kind of a ratio like I was talking earlier. And the ratio now is not 1-to-1, but it's pretty close. So we have 18, 15. So it's not perfect, but it's good enough. And now if we do the quick test again on that same testing set here, not bacon, we know for sure now that it is not bacon because we have improved our model. And as we identify other cases like that are definitely like not bacon, we need to add them to our model and keep on evolving them. So how do you even evolve your model, right? Well, we've just done it, right? We just have iteration 1 and we have iteration 2, and we have way more iteration as we move along. But on any of those iterations, it's possible for you to just publish it. So you're going to have a URL now that you're going to be able to call and use that to identify your model. Or even better, since we're using a compact model now, you can actually export it. All right, so where can you export your model? You can export it for iOS, which requires a Core ML format, or you can use TensorFlow, which is mostly for Android and any other serious machine learning jobs. We have an Onyx one, which is something different. We're going to talk in a different time. And we have like a whole Docker file that can include your model that it would be like for IoT Edge or Azure Functions or other scenarios like that. In our case, let's use TensorFlow because there's multiple reasons why you want to use TensorFlow. And there's, of course, like multiple version. I'm just going to use a full version. And then we're going to export it. So let's download the model. And let me just go back to downloads, and we're going to export all of this to Bacon model. Sorry, it's a different window. All right, we have a Bacon model. So what does that have? So this is our labels, the same labels we used earlier, bacon, not bacon, and it has our actual model. So the reason why it's compact is that this PB file, PB, by the way, if anyone is curious, is protobuf. So it's a serialization format created by Google that allows you to compact things like real small. So instead of using something like JSON, it's way more compact and way more tight in terms of size rather than JSON or, God forbid, XML, which is going to be massive. So in our case, we have around 5 megs, which is not out of the question for a mobile application or even IoT device, right? So now that we have a model, how do we use that somewhere else, right? So I'm not going to go through Azure because we could go through all the different like objects that we have on it, but let's not go through that. So I already created an Azure notebook, and I created an actual Jupyter notebook, and I uploaded the Steve export manifest, the labels, the model. I could re-upload the one we just trained, but it's basically the same thing. It's the same demo I do a lot of times, so we can re-upload them, but I'm going to save you some times here, and we're just going to open up the Baconator Jupyter notebook. So here, we just import of our TensorFlow models. We define our file names, our labels, already uploaded pictures of some bacon. And we're going to read that file name. We're going to parse from the string. So that we're going to read our model, import a whole graph. Then we're going to define a few functions that we're going to be using to basically filter out the pictures, because we're never going to be using the picture strictly as it is. Like, we're not using a 20 like wallpaper sized pictures. It's always something that's going to be pre-processed to be fitting the matrix of the machine learning model. So that's pretty much what we're doing. So we're cropping to the center, we're converting to different models, we're resizing to a 256 square. So all those kind of things needs to be done one way or another. And then we're going to use that. So we're going to update the orientation. So if the file already has some EXIF data and it's not in the right format, we're going to fix that. We're going to make sure we're in the right format. We're going to resize it down. And by going through all this process at the end, we're going to be, where is it called? Get it answered by name. Up the center. Yeah, so we're going to create our prediction, and we're going to run our session here by getting our tensor and creating our image and passing that image through that machine learning model. And then we're going to show exactly what it is. So I already ran it before, but let's run it together and just import that code as well. So I do Control Enter, like, is it bacon or not? So in this case, like, this is given bacon on top of bacon. Don't judge me. Those are weird pictures coming from the internet. People are having a hell of a fun with that. And basically here he says 0.99. That is definitely bacon. And we're not quite sure it is not bacon. But if we could add some pictures of cave and bacon, then at some point we could start to defer that model from like the result that we have here. So maybe that's another edge case. We need to make sure that it's covering, that we're not taking pictures of people like Kevin Bacon and pulling them into our model. All right. So we basically went through the whole process of training our model from basically absolutely nothing. And like, may I say no IDE, no code editor. We just went through the different process of creating our image. So let's go back to, just hope the slides work. So we built our model, we used our model in an app. Now, how does it work? Right? This is like, all this was super magical, and like, how can we do this? Most of the model you've seen today is what we call a convolutional neural network. So it's training a model from all the images that are existing in a massive terabyte size data set. So this is the kind of thing that the data that you need to train a CNN is kind of like massive. And a CNN is a deep learning model. And every time you read deep learning, tell yourself massive amount of data, because you need to run things on a crazy level. So how can we be able to run all of this with just like, what did we have, like 30 to 33 pictures in the end? And we had something that was quite accurate, right? How can we do that without requiring a massive amount of data? Well, there's a technique that is called transfer learning that you can use in there. And the goal is just that when you're training a deep learning model, it learns all the patterns at all the different levels. So it gets a color, it gets the shape, gets all the lines. It processes all those things, and it matches all those patterns to labels. And on our case, it's trained on an image set called ImageNet. So what do? We only retrain labels. That's how we can do it. But we keep all the learned patterns that was trained from ImageNet. So that allows us to save massively on the amount of time that we need to train a model that is really specific to yours. So think of it that way. So we're having those basic features that we're learning, like shape, colors, and like all those areas. Then there's more complex features that are built on those, and those are part of the net of the deep neural network. And at the very tippy top, there's the labels, and that's the only thing we're clearing out. Like everything else, the complex features and the basic features, is just a label is just a tag that says like this tag has that amount of like those value of complex features and those amount of basic features in the end. So we're just retraining the top. And that's what we're doing here. So what are the possible pitfalls? And that we covered a few of them today, but what you have to be careful is when you're taking picture for model training. I've seen that happen time and time again in hackathons, is people are using the same model. And by model, I mean the same person, the same object. So if they want to train an apple, they're going to take one apple and train that model on that single apple. Or they're going to be using the same room or the same lighting. I saw a demo fail on stage because they were training it in like one of those focus room where there was like some type of light. Then when they got up on the big stage where they had those big floodlight that like basically make you sweat by even like looking at them, suddenly the light was different and the model just failed. So you want to make sure that you're not training the model to identify your hand or the background or something else. You want to make sure it identifies the model. So what you do is you make sure that if you're using a model, you're turning it around, you're moving it a bit, you're putting in different contexts and different lighting. You want to make sure you're using maybe the same object but different ones. So if you're training apples, maybe not all red apples, maybe some are green or some have some shade of yellow on it. So you want to make sure that you're taking some varied pictures, because you have to take into account that it's just like training a baby. You have to tell them like, yes, this is an apple. No, this is not. And we kind of forget that we've learned a lot by just being told like, yeah, don't eat that. So those are kind of things that a model could really easily mistake by not having enough training data or not training it for this, right? Like it could learn from the color, but what if we just put it into in black and white? And then at that point, it becomes very obvious that we're talking about two spherical objects that both have a stem and both maybe have stickers on it. and both are a little bit shiny in the light. So it kind of becomes difficult to compare to both of them. So everything I've talked about is like all available. So if you want to do the same demo that I did and go through the same process, but you want to go like at your own pace, you can go aka.ms/bacon.bacon, really easy. If you want to run the demo that I've run in the Python notebooks, all the code is available on that second URL. And for more tips and tricks on how to improve a classifier that is like even more in depth that I just gave, that short link is going to really help you out, improve your machine learning model. And on that note, that's all I got. So if you have any questions, please in the chat on whatever window you are on, but otherwise it's my pleasure. Thank you.
All right, thank you very much. We do have some questions. So the first one is, what type of classification model does this service use? And is there an option to choose different models for the same data set to compare performance?
So the only models that we saw were the one that we had earlier. So this one, I think it's ImageNet in terms of data source. We don't have other ones. If you want to train your own model from scratch, you can always do so. And you can probably do the same thing, like taking something like ImageNet or RaiseNet or any of those models that exist and just retrain the labels on top of it. But it's a process you're going to have to go through manually and do it yourself.
Cool. The second question is, what would be some good indicators of a well-trained model among the three measures? I can see precision, recall, and AP display. Not sure what is AP.
Yeah, let me just reshare the screen because like this thing is very this is one of the things I like about our team is that we're very context sensitive here. So like this number will tell you if tag is predicted by your model and all likely it is to be right. So that's the precision, that's the recall. So those is like the amount of tags correctly found, and AP, I don't remember what it was. Yeah, okay, so it's a combine of both. So for me, I would go with AP. Normally I tend to try to get those all those numbers into the 80% and above for demo purposes. If I were to go for production purposes, high is good, but you never want to reach 100%, because if you reach 100%, there is something smelly already about your model. As in, you probably overtrained it because it should fail at some point, or it should be like not sure of what it is. But if it is 100% sure, it means you probably crossed the stream and you mix some training data and some testing data, and you're having some problem now. And
cool.
Stop share.
Thanks. There was an earlier question actually that I missed. How are folks actually using this in real life? Is that something you could speak to?
That's a good question. I don't have a customer scenario for that, but I've seen this model use this application used like 1,000 times in hackathons to identify different patterns. One that I found was I have multiple scenarios. So there was this guy that was trying to build a drone that would be taking pictures out of disaster area to identify where there would be people. So they would be using something like object detection to identify people from above. So you would need those kind of data. We had somebody that at a hackathon in Toronto that was using it to do Naruto and ninjutsu like detection image. So it was like doing this weird shit with his hand. Sorry, it was hilarious. And so those are kind of like, but you could do like hand recognition with those kind of things as well. There are better ways to do it, but that's one of the things that is possible. We had people try to recognize different type of images from automated systems. So when you're trying to upload something, for example, in your e-commerce, you want to make sure that it is the actual object that you're uploading, that somebody's not uploading a banana instead of an iPhone. So like those kind of system, you can try to get those models rolling pretty easily. It's one of the many scenarios, but as soon as you want to do object detection, like the license plate is one of them. Like it's not covering my scenario where I was just doing classification, but if you're using object detection, it's one of those scenarios where, yeah, you want to do that.
Gotcha. All right. The body wanted to clarify, because she asked about the good indicators of a well-trained model. Wanted to clarify, are the iterations independent of each other? As in, there is no influence of a previous iteration.
So the only things that you have is if you're going into the predictions tab, you're going to have all the images that were trained for that specific iterations. But they are independent. Only one can be published at a time, if I remember correctly. Let me just try it out real quick. And my dog is yapping again. No, multiple can be published at a time. So you can have iteration 1, 2, 3, 4, have 25 published, and you can export all of them. But if you want to delete one, you actually have to unpublish them. So if you're using a publishing URL, the thing is you're going to need, you're using Azure, so you're going to be billed by usage in terms of the amount of detection per week or per month. I don't know how we're billing that one. I'm not that much into the billing section, so I'm having fun with the services instead. And
All right.
But the cheapest one is always going to be to export your model, because then we don't track it. So you can use the exported model. It's a little bit less accurate than using the full version on Azure, but it's so much more portable, so much more easier to run on a drone, to run like in the wild, or if you're doing any kind of community work in a region where there is no access to the internet through either like the Wi-Fi or those kind of areas. It's getting hard. Another scenario that that was supposed to be part of the Imagine Cup, there was this group of students that had basically created a small model with plastic balls that you could install in front of your phone lens that would serve as kind of a do-it-yourself microscope, and they would be using that model to identify contaminated water with that.
Oh, wow.
So they just needed to run the model, but they could use that pretty much in the wild and like keep those pictures on their phone and sync that back with the model, retrain the model with the new pictures, and basically just work from there. So that was one of the examples.
Very cool. Thanks for sharing that.
And thank you for tolerating my dog.
Of course. And thanks everyone for those questions. All right, I will share my screen again. All right, so our next talk is about how micro of a micro framework Flask really is. Our speaker is Diana Rodriguez Martinez, developer advocate at Vonage. Please take it away, Diana.
Hi, it's Diana Rodriguez, actually. So,
oh, sorry about that.
All good, it's okay. I think my second last name is actually Manrique, but yeah. So, like Stella said, we're going to talk about Flask and how micro of a micro framework it is. And first of all, I'd like to introduce myself. If the slides actually work. Okay, they're working now. So who am I? My name is Diana Rodriguez. You can find me on Twitter. My Twitter handle is @katufa82, and my website is superd.dev. Superdi, sorry. I was thinking in Spanish. I also speak French, not as fluently as I would like to, but I think I can carry a conversation in French. I'm a Python developer advocate at Vonage, and I'm a Microsoft MVP. I'm an Azure ambassador and a lot of things. But the most important part of this is that I am someone who learns new things every single day. So having said that, knowing who am I, or being sure at least who am I, let's talk about who am I not. And certainly, I don't know if you know this woman, this is the Oracle from the Matrix. So it means I'm not the Oracle, meaning that I certainly don't know all the answers, but what I will share with you is based on my own personal experience as a developer. I would also like to warn you about a few things about this talk. The first one is that this is definitely framework agnostic. I believe in the weapon of choice philosophy, meaning that whatever framework, tool, language you choose, if it does the job, if it's right for you, if it's easy for you, then it's the right thing to use. And then obviously I'm not promoting any framework war, or I don't belong to the true church of Flask or the cult of Flask or anything like that. I'm just very passionate about this framework. And then this talk is full of what might seem as obvious examples. To give you some context, I will compare the two most popular, well, one of the many popular frameworks is definitely Django, and I will use Flask and contrast that against Django. There are many others, but I chose Flask for a few reasons that I will be sharing with you. So Django is a full-fledged suite in comparison to Flask, and we will be seeing how the main difference between both frameworks, Django being a full battery and Flask being a micro framework. So just in case to give some context, Django is an open source web framework. It follows the model template view architectural pattern, and it definitely eases the creation of complex database driven websites. And it's definitely a full battery suite. It's got everything you need out of the box. And then Flask is a Python micro framework based in, and I always pronounce this name wrong, Werkzeug, Jinja2, and the bestest intentions. And I say the bestest intentions, it's because the creator of Flask definitely had simplicity in mind. They wanted people to have the freedom to do, give or take as they please. And with Flask, we can definitely build web and RESTful apps in an extremely simple way. So when we talk about micro framework, I like to use a lot of imagery to introduce concepts. I'm in the autistic spectrum, so these things actually help me understand so much better. So I'm thinking, if I had to compare a framework as a team, say the Avengers, I would say a micro framework would be like one of the Avengers. In this case, I chose Doctor Strange, which, by the way, is one of my favorite Avengers. I'm changing my mind every day, but Doctor Strange takes the cake. So another way to see a micro framework, well, this is a sample architecture of a micro framework. It basically has the bare minimum to deploy your applications. So it's routing and it's login, and that's it. There's really nothing more out of the box. I also like to see micro frameworks as building blocks or Lego blocks, where you can actually assemble pieces at will. You can add or take pieces as you wish. If we compare this to the Django architecture, then we can think of a more complex architecture, a more complex pattern. And this is, don't mind my poor drawing. I just wanted to show you in a way what the Django architecture is versus what we saw before. I would also compare it to a whole team, and Django would be the equivalent of the All Blacks, the New Zealand rugby team, even with the haka and everything. To show you more or less what I like about Flask as a framework and why do I really think this is more mighty than anything, I would say that you can build a Hello World app in less than 10 lines definitely, and no complication. So this is a hello world. I used it for PyLadies and I liked it so much that I kept it for this talk. The syntax is beautiful. If you look at the right decorators, it's pretty straightforward to read. And that's something I love. It's one of the selling points from Flask. It's a common pattern in Flask, and it's one of the reasons I love this framework, because of how readable the code is. And for those who write APIs without frameworks, Flask actually offers simplicity and performance. So the result of these 10 lines, where we are importing Flask, instantiating Flask, running our main route, which is just, slash, meaning the main route, and adding our logic, and then running our app in main. The result is something like this. Very simple, in 10 lines of code. But well, like every good tool, we have to think about pros and cons. And I would say, in terms of pros, the learning curve is not steep at all. It's actually really good for those who are getting started with Python, and for those who come from other programming languages, it's pretty good to catch up. It's a production-ready framework, which means you can test your deployments live. It comes with its own server, so you can run it, so it's production-ready. The writing is actually really good. As we saw in the previous slide, the syntax for the route decorators is beautiful. It does support sessions and cookies. It's an extensible framework, and something that many might see as a con, I see it as a pro. It doesn't come with a baked-in ORM or an admin panel, and that gives you the freedom to choose what ORM you want to add. I like SQL Alchemy, or mostly SQL Alchemy in terms of ORM for Flask. And now in terms of cons, and obviously also something else that is really good, and it's also a selling point for me, is the excellent documentation. Now, in terms of cons, there are none. Nah, I'm joking. It might be complex for big apps, because too many moving parts can basically take quite some time in terms of development. In terms of the community, well, the community is smaller in comparison to Django, which means that sometimes finding solutions to, common problems or things that occur, in your development process can be complicated. But then this is a good chance to create something new, or to bring up those solutions to the community as a good way to contribute, right? So I would say, after knowing this, the most common questions people can come up with are, is Flask for small projects only? Not really. In the world of Flask, there are hundreds of dependencies that will help us create projects that are robust and scalable. So you want to connect to a database, you can implement whatever ORM of your choice. If you want to version your API, there's certainly a library to meet that need. Do you want to integrate migrations and an interactive shell of your models? Of course you can. I personally recommend Flask Manager. So really, the community is really active in this particular aspect. And a lot of things that are native to Django, you can find them as Flask dependencies. And if not, then it's the greatest chance to create something new. Another question that is pretty common is, why is it called a micro framework? I would say, don't let the word micro framework confuse you. Everything you can do with Django, you can do it with Flask. No doubt about it. If you want to define routes, if you want to work with forms, if you want to render templates, if you want to send emails, if you want to define unit tests, all and much more. And whatever doesn't exist can be created. You have the freedom in your hands. Another question would be, can it do everything Django does? Definitely, yes. And also a good question would be, when should I use Flask instead of Django? And I think the right answer, well, there's never a right answer, but for me would be, if you're working with microservices, if you're working with serverless architectures, if you're working with IoT, definitely, yeah, because running a Flask server in a Raspberry Pi, because of the simplicity of this framework and how lean it is, it's perfect for all these scenarios that I spoke about before. Moving on, full stack Flask, is that even possible? Well, definitely. Flask can be coupled with the most common web frameworks. I've used Flask and React, Flask and Angular, Flask and Vue, and the latest one, Svelte and Flask. And I actually found a really good tutorial. I'm going to leave you some links and resources. I got really excited about it because it worked like a charm. Now I want to share something about Flask in action, and this is a very personal thing. I will share insights about an app that I built myself. You can see the URL in there and the repo. This is obviously a Python app with Flask, Materialize CSS, and Jinja for templates. And to give you some context, I have type 1 diabetes. I belong to the faulty pancreas club. As a matter of fact, I have a spare insulin pen in my hand that I will probably need to use because my insulin pump is not working right now. But there's a URL in this slide, dianox.superdi.dev. And there, if you get curious and hit to that website, you will see something like this. This is a dashboard where you can see my blood sugar levels in real time. And it's part of an open source project called Night Scout. And it's a web-based continuous glucose monitor that gets glucose data in real time. And it's really cool because values are predicted 30 minutes ahead using an autoregressive second order model. So this reads from a MongoDB containing data from this sensor that I have in my arm, and then alarms are generated for high and low values. But what happens? So I have my sensor, and this sensor is connected to my phone. I have it here, and then I can either tap straight to this sensor using open source technology, or I can send the data from the official Dexcom app, which is what you're seeing now, to my dashboard. And then based on that information and all the predictions that I made through Night Scout, I can make better decisions and summon my pump and give myself the right amount of insulin. But what happens? My phone and all these devices and even a Night Scout dashboard have alarms. But in moments of crisis, it is difficult for me to hear them, even when I'm sleeping. I can't hear any of the alarms. And if you see in the screen, there are two values in there, like a really high blood glucose value and a really low one. But strangely, I can always hear my phone. Oops. Which is why the idea was to make my life and the lives of those fellow diabetics who have my same struggles easier, taking advantage of the simplicity of Flask as a framework and using the Vonage APIs. So how? So we have a range of values, say 70 milligrams per deciliter as a low, or 3.9 millimoles per liter. And for high would be 180 for me here in the United States, or 10 millimoles in Europe and Canada. So I can grab readings for the last 60 minutes or any given time frequency through a Python thread with a scheduler, and I can use SMS and voice APIs to notify myself and my emergency contacts of these irregular situations with my blood sugar levels. So if ranges are below or higher than what it is configured through environment variables, then it fires an alert. And there's also an alert if it doesn't get data for a set period of time, if I were offline. And then in this case, it sends a message to all my emergency contacts saying that my blood glucose data is not coming up, it's not online. And then if I wanted to, I could run a second scheduler to obtain fresh data. And this is what it looks like. This is a simple Flask application that allows me to log in and configure my Night Scout, the dashboard we saw before, details. And in this case, for me, the easier way to do so was with Google Authentication. And this is how it looks. It's a very simple app. It doesn't have like, can you hear me? Okay, so yeah. So here I can configure the entries endpoint to grab my blood glucose readings data. I can configure my phone number to receive a call if my levels are out of whack. I can configure an emergency contact, and in this case is my mom, who will get notified should I not pick up the phone. And then up to 5 additional contacts who will be notified should either of them not pick up, one by one. So it will call them, it will call me, wake me up if I'm asleep, and read my blood glucose values and say, hey, Diana, you're high or you're low. If I don't pick up, it will call my mom. And if my mom doesn't pick up, it will call my contacts. And at the same time, it will send an SMS notifying all of us of the occurrence. Let's have a quick run through on the technical details that make developing this app an enjoyable experience. So I will share small bits of code. Nothing too complex, just to show the highlights of why Flask was actually the right choice for me in this case. So to make a views, Flask uses Jinja as the template engine, and it's pure HTML. So that's already something most of us are familiar with. In this case, we have a parent template defining content blocks that will be used by children templates. So these blocks will display the code from those children templates. If we see, that's one of the blocks. So these files are located in a template folder inside of a static folder. And then we can see something really cool in here. It's a URL for function that points to JavaScript and CSS in that static folder, which is a comfortable and elegant way to point to CSS libraries or something like the Vue.js CDN if you want to work with Vue from the CDN. It's actually much easier and easier to learn, definitely. I'm going to show another template, and if we see in this login.html, if we see the extends layout.html, we can tell how login inherits from that parent template called layout. Then the renderer will load layout with whatever variations we add to our login file. And these variants will be defined within the blocks that we set in layout. For example, in here, I'm using the head block in this case. And then whatever logic I want to add, that is just like a placeholder I used in there just to show you how it works. If we go to the Python side of things, we for the login side of everything, I can specify the root and the method if applicable. In this case, for login, I'm calling that function and then just write your logic. But if you want to know more about this application in particular, I wrote a tutorial on how to build a Night Scout notifier with next mode messages and Python. These are Vonage communication APIs. So this is a URL. I will leave a link to these slides anyway. And if you're also interested in knowing the exciting ways and a work in progress project, sorry, my sugar might be, yes, my sugar is a bit high, which is why I've been slurring a little bit, but I'm okay. This is the URL for an exciting project that I'm building along with another developer advocate whose name is Kelly Andrews. We're building an online karaoke room with React, Flask, and the Vonage video APIs. So in conclusion, Flask is an awesome option if you're starting your journey with Python, and if not, it is a great option as well. It's not limited to small projects only. You can add or take at will to meet your needs. And once you gain proficiency with Flask, moving to Django will be very easy, or maybe you won't need to move at all. So thinking about it, Flask as a micro framework, I would say it's more of a mighty framework. You can do so much. And this is a perfect analogy with my favorite Avenger, Doctor Strange. If you want access to all these resources, you can go to slides.com/superdiana/flask-micro. All those links are there. Again, thank you very much. It was a pleasure to talk to you. Apologies that my blood sugar actually started playing on me. Maybe the excitement of being here with you. And again, I leave this page for you all to take a screenshot or take a look again. It has all those resources. Take a look, especially the Svelte tutorial is something exciting. So I'm going to stop sharing my screen and I'm ready for any questions if you have any. I'm going to see here. Oh, thank you, Noreen, for posting the links for the tutorial and for the for everything else. But yeah, if you have any questions, let me know. Thank you, Maxime, for posting the links, and thanks for the comment. I love making slides with lots of images. It's one of those things that makes me happy.
It was a great talk, by the way.
Thank you. Thank you, everyone.
Thanks, Diana. Can't wait to try that tutorial out. Sounds awesome. All right. So thanks, everyone. I think there was one last question for Rosetta, if you don't mind, Rose. I think I missed it.
Yeah, I saw that later too, and yeah.
Yeah.
Let me just find it again.
I can read it out. Got
yes,
it
please.
Over here. What would I use besides Docker, and what are you building with containers at FluCat? Are all the apps broken into microservices where you work?
So I'm not exactly sure about what other software there is other than Docker, and I think it's something called Rocket something, but it's not something that, like, it's Docker has really dominated space, so it's not something that I've heard about even. Like, that's how not a competitor, I guess it is. At FluCat, we make DNS software. So basically, it's for enterprises. It's software that sits between employees and the internet. And it basically does the work of a DNS name server while providing a lot of value to the enterprise. And yes, we do all of that, all of the functionality of that product with microservices. For example, logging and actually answering queries. All of that gets done through microservices. I hope that answers the question.
All right, thanks so much. Want to thank all of our speakers again. Thank you very much. Those are really great talks. We have this recording and we'll send it out in the meetup page. Thanks everyone for taking the time to join this event, and we hope to see you again at our next remote one. Have a great evening, everyone.
Thank you. Bye-bye.